All right, let's talk about something that's, well, a bit of a nightmare scenario in any data center: a huge physical failure. We're going to break down a really clever piece of tech called vSAN fault domains that's designed to make sure if that nightmare happens, you don't even notice. So let's just paint a picture here. Imagine it's, I don't know, 3 a.m. and an alert just starts screaming. An entire server rack, poof, it's gone offline. Maybe it's a power failure, maybe a top of rack switch died. Honestly, it doesn't really matter why. The point is, it's dark. And this is the big question, isn't it? What happens next? For a lot of setups, this is catastrophic. We're talking a major outage. Your applications crash, data is suddenly unavailable, and now you've got this frantic, all-hands-on-deck scramble to recover. This single point of failure is exactly the kind of high-stakes problem we need a smarter way to solve. Okay, to really get our heads around the solution, let's actually step away from all the technical jargon for a minute. Let's think about it in a much simpler way. I want you to imagine your servers are like players on a sports team. This is the core idea right here. It's not about having one giant superstar team where if one key player goes down, you're in trouble. No, it's about having multiple independent teams that have each other's backs. So if Team A's bus gets stuck in traffic or, its server rack loses power, Team B is already on the field, they have an exact copy of the playbook, and they're ready to go. The game just keeps going, no interruption. And this is where the analogy just clicks perfectly with the technology. You can see it laid out right here. Your Team A and Team B, that's what vSAN calls fault domain 1 and fault domain 2. The fact that they're physically separate, well, that means they're literally in different server racks. The duplicated work is your mirrored VM data. So when one team has a problem, a rack failure, the game keeps going. Your apps keep running. That's high availability in a nutshell. Okay, so the whole sports team thing makes sense. But how does that actually work under the hood? Let's pull back the curtain and see how vSAN actually pulls this off. So here's the official definition. A vSAN fault domain is basically just a way for you to tell the system, hey, listen up. All these servers, they live together in rack A. And these servers over here, they all live together in rack B. By creating these logical groups that mirror your physical world, you're giving vSAN the awareness it needs to protect you. It's that simple. So it all breaks down into 3 pretty simple steps. First, you group your hosts. You tell vSAN which servers are in which rack. Second, and this is the clever part, when you create a new virtual machine, vSAN automatically goes to work. It's smart enough to place the VM's main data in one domain, let's say rack A, and its replica, its mirror image, in a totally different domain, like rack B. And third, this is the magic. If rack A goes completely dark, vSAN doesn't even flinch. It just instantly fails over to that mirror data in rack B, and your applications stay online. Your users never even know anything happened. So you go through this setup, and the payoff is huge. This isn't just some cool tech for the sake of tech. It leads to some incredibly powerful, practical benefits for keeping your stuff running. And here they are. First, you get what we call rack awareness. Your storage system is no longer blind to the physical world. It actually understands its surroundings. This directly leads to the second benefit, enhanced availability. You're basically building a shield around your services against these big hardware failures. And finally, this whole concept is the bedrock, the foundation, for even more advanced setups like stretched clusters, which can protect you from an entire site failure by spanning 2 different locations. So, as we bring this all together, what's the big idea here? What's the main thing we should really walk away with about how we design our digital foundations? It's this right here. Using fault domains is a fundamental shift in your thinking. You're moving away from a reactive mindset of disaster recovery, which is basically just cleaning up a mess after it happens, and you're moving toward a proactive strategy of built-in resilience. You're actually architecting a system that expects failure, that anticipates it, and is designed from the ground up to just handle it gracefully. And really, that's the question I want to leave you with. Take a hard look at your own environment, your own infrastructure. Is it just built to run, when everything's perfect? Or is it truly built to survive when things inevitably, and they always do, go wrong?